I would like that we carry on. We are on time, so let's be like that. All the day long we've been on schedule. And if you want to then enjoy the network party and afterwards probably Christmas market, maybe we have to get back to the main presentation. So the next topic is the update on the CARI, so the continued airworthiness review item on the main gearbox. And I'm glad to introduce Marco Dioli from EASA.
Thank you, David. Good afternoon, everybody. I hope you are tired enough to follow me, but not to ask questions at the end, of course. Questions are welcome. As introduced by David, we are talking about continued airworthiness review item. For those of you who are not familiar, that's the tool that we use within EASA to track a discussion involving continued airworthiness topics. It's kind of similar to CRI, you may be more familiar with, but of course happening after the certification of certain parts. I would like to give an update mainly to the TC holders that have been involved into the CARI process, and of course present it to everybody else who are not familiar with it. CARI are not public documents, so this presentation aims at presenting actually what was this initiative of EASA's. We will go through the origin and the scope of the CARI 2901, a little bit of feedback on the collected data, and possibly the most important part and the takeaway for you is the EASA approach on the lesson learned from these events. The scope and the origin of the CARI is coming from the technical evidences originated by the Super Puma accident of the Eleno GEF, happened on the 29th of April 2016. The technical elements are actually coming from the IBN investigation report. IBN is the Norwegian Accident Board for Investigation. And the Airbus helicopters activity in frame of continued airworthiness with EASA. Activity is a little bit reductive. It was really intensive and really extensive. Believe me when I'm saying that. I've been following that only for 2 years, but it's the amount of work, hours spent, and discussion is really amazing. So let's have a look at the elements coming from the reports and the continuous airworthiness activity. On the top left, you can see what was the failing component causing the accident. It is the outer race of a planet gear installed on the second stage of reduction of the main gearbox of the Super Puma. The investigation highlighted that a crack originated from the contact line between the roller and the outer race, went subsurface until it turned, went into the rim, and caused the separation of the two surfaces. After the separation, the planet gear meshed with the following planet gears and caused the rupture of the main gearbox. You may have read the EIBN report, which is a public document, so you may know a little bit about the story. We will just go briefly through that. The investigation highlighted also that there was a very limited spalling. Look at the left middle picture. Involved before the crack went through the rim. It was estimated surface of 28 square millimeters. I don't know if you're familiar with surface of spalling. It's really limited in this case. And it highlighted also, bottom left picture, that there was a development of micro-pitting on the maximum stress contact line with the rollers. So these are all elements that were coming from the IBN report. On top of that, and you can look at the top center picture, we highlighted that the existing chip detector's performance may not be adequate to detect this type of failures, especially considering the limited spalling that we have seen before. This means that spalling, which is traditionally considered a benign type of failure because there are no major ruptures immediately associated with that, but spalling is produced and is catched by the chip detectors installed on the transmission. This is enough to actually stop the operations and do more, let's say, in-depth investigation and maintenance and change of parts. On the top right picture, we also got the evidence that the maintenance criteria introduced into the ICA following a chip detection may not even be adequate for the limited spalling as in the LNRJF case. We have quoted here the total area accumulated, which is a typical parameter. Operators are collecting particles, but they are actually doing maintenance only when the collected surface reaches a certain threshold, which is published. And of course, again, the very limited spalling that was associated with this rupture may be posing a risk before the existing limits are met. Other elements, and they are recapped here, are more dealing with some design criteria. We mentioned contact pressure, which is the Hertzian contact pressure between the roller and the outer ring, the surface hardening, and we put it here as inadequate inner versus outer race contact pressure ratio, which is saying that, of course, if you have a higher pressure on the inner ring, you can have spalling, abundant spalling on the inner ring that is catched and the aircraft is stopped for maintenance, while if it happens on the outer ring, it may be a problem. So we also know that as fuse effect from our discussions with Airbus helicopters. Of course, if you manage to have the inner race spalling before the outer race, that's a safety device somehow. If you have the vice versa, you may be in a situation prone to danger. And also, of course, the level of stress through the rim may increase the likelihood of subsurface cracking. We do not have a recipe, otherwise the recipe would be on the board. So what we are saying is that these elements may increase the likelihood of these type of events. Finally, bottom right part is return from service, meaning that mostly parts of this kind during overhauls are scrapped because of different reasons. They may not reach necessarily the planned and certified life limit because they present corrosion pits, dents, other type of damages, so they are, let's say, removed from the maintenance. This, of course, might prevent the identification of a significant subsurface damage. And this is traditionally what happens and what have happened in the past. So summing up these elements, we thought it was a good case to share this with other OEMs which share some part of the design or which have design similarities. Typically, epicyclic reduction stages are very common on helicopters. And considering that not all of these elements are self-evident, there could be the risk for hidden risks on other platforms. For this reason, we prepared the CARI 2901, and we released the CARI to the other TC holders of CS JARFA 29 helicopters. So the CARI is about fatigue cracking in MGB critical parts with integral bearing races. Integral bearing races is in the end the type of component that we were after. CS29 helicopter, we started with 29. We may go to 27 as well. Most of the TC holders involved into this survey already provided data about their CS27 helicopters. But of course, typically, the the loads involved in 29, and also the fact that they are passengers, typically passengers-rated helicopters, drove us to target them at first. And the reason I reported it here is that we, in the end, figure out that the accepted means of compliance, accepted so far, have not adequately addressed the risk associated to the following points: rolling and sliding fatigue on bearing races, bearing design parameters affecting reliability, performance of the debris monitoring systems, and continuous integrity verification of critical components. We will we will go back to these points when we see the last slide. So the CARI is actually asking these points to the involved TC holders. About bearings, we are asking if the TCH knows or has under their records cases of through cracks, especially on the outer race. Details on these cards due to outer ring damages, again. And what are the design parameters of critical integral race bearings? Of course, this part was not for us to necessarily know all the details of a design, which, by the way, we are entitled to have for certification, but also to try and understand if, with the knowledge we have gathered during the continuous airworthiness process following the 225 accident, there were some ringing bells for any risk, specific risk. The other question was about oil debris monitoring, and actually you can see it. We asked if there were failures detected by chip in order to possibly build a performance index. What was the spoiled area when spoiling events were recorded? What were the methods for establishing the detection performance at design, and if any reassessment was done during due to in-service events? ICA criteria for particles evaluation, again, maybe total accumulated area, or what is the mechanism driving from particle detection to removal of the MGBs or further maintenance. And what are the overall criteria for rejection of integral race bearings, again, level of dents, pits, and markings. I stress the fact that the return from the field is highlighting first of all, that these transmissions are unfortunately not always working in an ideal world. You know very well that flying in certain conditions exposed to water, and for instance offshore helicopters are a primary target, means that you may have water content accumulated in the oil. You may have particles coming into the gearbox due to oil change, due to the presence of sand in specific environments and so on. And so what has traditionally been the way to certify these gears, so like typical endurance test and so on, may not have fully shown all the threats that are potentially affecting the planet gears with the bearings with integral races. We have collected data from all the involved European manufacturers, of course. Following the bilateral agreement provisions with Transport Canada and the FAA, we have also collected data from almost all the applicable Canadian and US manufacturers, and of course we thank Transport Canada and the FAA for the help on this topic. We have data. It's not easy to make it comparable apple to apples, but so far we highlighted no specific risk emerging from what was reported and what was the in-service experience. Keep in mind that this for us is not an exercise that stops at a certain point. Figure it out more as a continuous exercise. So we keep receiving data, we keep receiving feedbacks, and based on that, we raise or lower our attention. So in the end, what is the lesson learned, and what is what can you expect from us after this gathering of knowledge on this event? Well, first of all, the design assessment of gearbox components should consider the effect of cracking of bearing integrated race. So we will ask from now on what happens to your transmission in case you have cracking of one of these type of components. Don't be surprised. The second point is the review of the design parameters and analysis to evaluate the likelihood of spalling and cracking on bearing races. Again, this will be on you. You will have to tell us based on the level of stress, based on the thicknesses involved, what is going to be the likelihood of spalling based on all these elements. The third point is the characterization of the bearing spalling and spalling detection, which needs to be supported by demonstration of an adequate chip detection effectiveness. As I said before, if the planet gear, even if it spalls, never cracks, or even if it cracks, never jams the transmission, that may not be that important. But of course, if the planet gears cracks and that jams the transmission, and the only barrier between this situation and the failure of the transmission is the chip detection needs to work, and you will have to prove that the chip detection is effective. And that's, as I said, it's a huge step also on our side. The last point, of course, is the justification of the ICA criteria and overall criteria for particle identification and inspection removal criteria. Everything, as you can see, is linked. So what I would like you to keep from this presentation is the fact that based on this event, we may develop, we are already doing something on certification memorandum, but we may develop, let's say, an increased attention on integral races, bearing with integral races. And again, don't be surprised if the next time you want to certify transmission or the next time there is an event somehow related to these aspects, all these elements will be requested. And that's all for me. Thank you.